So let's talk about stats. I know we talked about it last tutorial, but I still want to refresh your memory because when we deal with function like proving the image of the function, it's actually we are dealing with set because the image of a function is just a set. So if you have x is in A intersect B, it means that x is in A and x is in B. If x is in A complement, it means x is not in A. If x is in A union B, it means x is in A or x is in B. I want to ask you that if we know x is in A or x is in B, can we conclude that x is in A intersect B? Can we conclude this? Yes or no? No, 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 no. Yeah, we cannot. This one is wrong. We cannot say this because if you look at the Venn diagram, then if x is in A union B, it means x is in here, right? So x can be in here or here or here. It doesn't have to be in here, right? So x is in A or x is in B doesn't imply x is in A and x is in B. That is wrong. However, if we have x is in A and x is in B, we can conclude that x is in A union B. Why? Because if A and B are not disjoint and x is in A and B like this, it means x is inside this one. And this is A union B, right? So that's what I want to talk about. From this, you can imply x is in A union B, but if you have x is in A union B, you cannot say that x is in A and B. So x is in A intersect B complement, it means x is not in A and B. And it means x is not in A or x is not in B. If x is in A union B complement, it means x is not in A union B. So this step, I just use this definition. If x is in something complement, it means x is not in that set. And if x is not in A union B, it means that x is not in A and x is not in B. And if x is in A exclude B, it means x is in A and x is not in B. Okay. So the next thing we will talk about is function and its related term. So you can think of function as a machine when you give it input and it will give you the output. So that's what the function do. So in order for it to be a well-defined function, let's say this one is domain and this one is codomain. In order for it to be a function, then every element in domain have to be mapped to some point in codomain. So you can map it like this. But if you have a new element here and you don't map it to anything, which means there is something in the domain that cannot be processed by the function, This is not a well-defined function, okay? In order for it to be a well-defined function, every element in the domain has to be mapped to something in the codomain. And let's just draw a new domain here. If you have something like this, like one input is mapped to two output. This one is wrong. It is not a function. This one is not a function. One input, like one element in the domain, can only have one output. It has to have output and it can only have one output. So one dot in here can only be mapped to one dot in here. If you map one dot in the domain to two dots in the codomain, it is not a function. However, if you have something like this, two elements in the domain, which means two input, have the same output, it is okay. This one is okay. This one is a function because every element in the domain is mapped to something in the codomain, and nothing is mapped to 2-point. Like it is not mapped to 2-point like this, and only to 1 point. And similarly here, only mapped to 1 point. This one also mapped to 1 point. This one also mapped to 1 point. So it is a function, even though these two have the same output. You can think of it as like this set is kitten and this one is adult cat. Then every kitten needs to have a mom, right? And it can only have one mom. A kitten cannot be have than more than one mom, right? And two kittens can share the same mom. It is okay. However, not every adult cat have a kitten. It's also okay. So this one is a perfect function. And another thing is image. Image consists of points in codomain that is mapped to a point in domain. So of course, everything inside this set is part of the codomain, okay? Everything inside here is codomain. However, not every point belongs to the image of the function. The image of the function only consists of this point, and this point, because they are the only 3 points that was being mapped to something in the domain, okay? Only these 3. This one is called f of the domain, or you can call it as an image of the function or range. They both mean the same. And this whole set, this whole circle here is the codomain. So if you have an element x, you know that it is in the image of f, then you can say that x is in the codomain. It is correct, which means image of f is subset of codomain. However, x in codomain, you cannot make sure, like you are not sure that x is in image, right? Because look at the example again. Not every adult cat have a kitten. So if you pick any random adult cat inside this set, it's not 100% that it has a kitten in this set. However, if you pick all the red dots here, they are the cats that have kitten. You know for sure they are in the codomain, so the set of adult cat. Does this make sense? Okay, good. So something really help us in the proof is we write the definition of something belong to the image. So here I say image consists of points in codomain that is mapped to a point in the domain. So if we translate it into something like have more notation, like more symbol, we can say f is a function have domain A. This one is domain, and this one is codomain. Then an element y belong to the range of f if and only if there exists. Let's just write in word. There exists x in the domain such that fx equal to y. So we will always use this definition in proving the image of a function. In order to prove the image of a function equal to an interval, so this is just notation for the interval, we have to do two things. Because the image of a function is a set, an interval is also a set, as I said in previous tutorial. In order to prove set equality, we have to use double inclusion. So first step, we have to prove the image of a function is subset of the interval. This step is normally easier than the second one because when you find what is the image of a function, you kind of just do this step already. And step 2 is not as familiar with you guys. So you will have to prove the interval is subset of the image. So in the first step, in order to prove this is subset of the interval, we have to take y in the image. So y equals something. So for example, fx equal to absolute value of x, then we will say y equal to absolute value of x. If fx equal to x squared, we will say y equal to x squared, right? So this part is just plug in what is the function that they give us. Plug in function, okay? And fill in this blank. So y equals something for x in the domain. Our domain here is A. It will change depending on the problem. Sometimes the domain is a real number. Sometimes the domain is natural number. Okay. And next step, we just need to prove that A is less than the expression that we write in here, and less than B, because it is the interval AB. If you have square bracket here, then it will be less than or equal to. If you have square bracket here, it will be less than or equal to in this place. So please change it and adapt to the problem, but this is the general template. And once you got to this, it means A is less than Y and less than B, which means Y is in the interval. So we started with Y is in the image of F, and we end up with Y is in the interval. So that proves the image is subset of the interval. And in the second step, we want to prove that the interval is subset of the image. Then we have to take some elements from the interval. And in order to prove the element is in the image, we use this definition. So we will show that there exists X in the domain such that fx equal y. So in here, in the rough work, you will have to solve for X. And in your proof, you will be like, take X equals something and argue why X in the domain. And then you plug this value of X inside the function fx and do some computation and show that it's equal to Y. So that is the idea of how our proof will be structured. Let's move to the first question. I will create a poll for you to vote. In here, I want a tight lower bound. So like the largest number such that it is less than or equal to fx. Okay, 10 more seconds for you to vote. Okay, so I want the largest number such that it is smaller than or equal to f of x. So if you have 3 is less than or equal to f of x and 2 equal than or less than or equal to f of x, then I want 3. What methods are you use for this kind of question? So normally when we ask you to find the image and prove it, we don't care about how you find it. You can use calculus if you want in your rough work. Like that's actually make the problem easier. And for the lower bound, normally I would think about if there is something greater than or equal to 0. Okay. So most of you chose C, then A, then B. So C is the correct answer because so let's say you know that x squared is greater than or equal to 0, right? Is basic fact 2. Then 3x squared is also greater than or equal to 0. And x squared plus 1 is greater than 0, right? And these are two non-negative number. So when you have positive number divided by positive number, it gives you positive number. If you have negative number over negative number, it gives you some positive number as well. X squared plus 1. Yes, that's correct. Is greater than or equal to 1. But then it still means that it is greater than 0, right? What I care about here is the sign of both numerator and denominator. I care about like whether they are positive or negative. So I know this one is non-negative, so it includes 0. So when it is equal to 0, when numerator equal to 0, then the expression will be 0, right? So it actually can achieve 0. And when this one is greater than 0, then the whole expression is positive over positive number, which is a positive number, greater than 0 as well. So 0 is the smallest value we can get here. Does it make sense? However, if you have a positive over negative or negative over positive number, it will be less than 0. And if the numerator is 0 at one point, then the whole function will be 0 at that point. Okay, let's vote for the second one. In the test, we just care about how you prove it. We don't care about how you got that number. So in here, I want to tie the upper bound, of course. So for example, if the function is here and is less than or equal to this point, then of course it's true that if you pick any number over here, the function is less than that. However, I want this point. I want the tightest upper bound. Okay, 10 more seconds. Okay, most of you chose B, which is really good. Because if you know in calculus, as x approach infinity, fx will approach 3, right? It is like limit of x approach infinity of 3x squared over x squared plus 1. It will be limit of x to infinity. You divided both numerator and denominator by x squared, you get 3 over 1 plus 1 over x squared. As x approach infinity, x squared will get extremely large. So 1 over x squared will approach 0. So the denominator will approach 1 plus 0, which is 1. So the whole fraction here will approach 3 over 1, which is 3. Okay. So let's vote for this one, then we will go to the proof. Will this method work for other function? It depends. If it is a fraction like this, normally you can find the limit of it. I mean, like, you can find the limit of a function to see what is it upper bound. Like if you are able to actually do that. It depends on whether you are good at calculus. The image of function that have Cartesian product. I will go over that one. I will go over the previous quiz. It really depends. I cannot give you a fixed answer because different problem will require different thinking, but the key is you have to observe like whether there are anything to stop the function from growing. If not, the function will just growing to infinity. Ten more seconds. And for the minimum value, I will observe whether there is anything in the function that is greater than or equal to 0. Because I mean, in this course, you learn about basic fact, like x squared is also greater than or equal to 0. Absolute value of a number is also greater than or equal to 0. Square root of a number is also greater than or equal to 0. So yeah, I just use those facts. Most of you should see really good. So we talk about here, this one can actually achieve 0, right? Because 3x squared is greater than or equal to 0. So when x is 0, the whole function will be 3 times 0 over 0 plus 1, which is 0 over 1 and equal to 0. So 0 should be included. So the square bracket is good. However, it should be round bracket in here because it's a definition of limit. Like you are just approaching it. You are just getting closer and closer to it, but you cannot really touch that point, right? So that's why it should be the round bracket here, and we will actually prove it. So we want to prove f of r because here the domain is r. The domain here is r. That's why I call f of r is the image of a function. I will prove it is a subset of 0 to 3. So first step, that is first step. So I pick an element from f of r, then y would be equal to 3x squared over x squared plus 1. As I said in the form here, why not use lim to negative infinity to lower bound? Okay, because as x gets smaller, it doesn't like, if you draw the function, you will see that as x gets smaller, the function will approach something similar when x approach positive infinity. It depends on the shape of the function. Sometimes if you can graph the function, you can see what is the upper bound and lower bound as well. Okay, so we have y equal the expression for f of x. I'm just using the form I gave you in the beginning. For some x in the domain here is r, right? And I want to show that 0 is less than or equal to y and less than 3. So the first thing I have is x squared greater than or equal to 0 by basic fact. So 3 times x squared is greater than or equal to 3 times 0, which is 0. Okay. And x squared plus 1 will be greater than or equal to 1, which is greater than 0. So 3x squared over x squared plus 1 is actually greater than or equal to, sorry, not greater than, yeah, okay, is greater than or equal to 0. Because this one is a non-negative number, and this one is a positive number. So that's why it is greater than or equal to 0. And the second thing is we have to prove it is less than 3. So in our rough work, I would write 3x squared over x squared plus 1 is less than 3. And I multiply both sides by x squared plus 1 because it is a positive number. So I can multiply and it doesn't change the direction. Then I divided both sides by 3. And I'm left with 0 is less than 1. So this is my rough work. In my proof, I will say 0 is less than 1. So x squared plus 0, which is x squared, is less than x squared plus 1. This one is x squared plus 0. Okay. and I times 3 to both sides, and I divided x squared plus 1 to both sides, and it doesn't change direction because x squared plus 1 is a positive number. And when you divide something, you have to think whether it is 0, because if it is 0, you cannot divide. And here it is strictly greater than 0. That's why I can divide by x squared plus 1. Okay? So what I just did is proving fx is greater than or equal to 0 and is less than 3 and y equal to this expression here. So that's why I know 0 is less than or equal to y and less than 3. So y belong to the interval 0 and 3. We started with y is in f of r, and we end up with y is in the interval 0 and 3. So that's why f of r is subset of 0 and 3. The next thing we have to do is prove 0 and 3 is subset of f of r. So you will take y from the interval 0 and 3. We need to find it out. Yeah, that's why I let you vote. Like, is the process of thinking what is the potential image, and in the proof you just have to prove it, because we don't care about how you get your image. Yes, we just care about the proof part. Like, first, if this one image is subset of the interval, and secondly is interval is subset of image. So that's what we mark it for. We don't mark about the process. How did you come up with it? So let's take y from this interval. Then I want to show y is in f of r, which means I want to show that so we can even graph it. Yes, of course you can. So you can, what I'm talking about. Okay, so I want to show this, which means I want to show x is x in R such that fx equal y. Because this is a definition of image I talked about earlier. So in my rough work, I will be like solve for x such that y equal to f of x, which is 3x squared divided by x squared plus 1. So in my rough work, I'm actually solve for x. So I multiply x squared plus 1 to both sides, and I move 3x squared to the left, and I factor x squared out. And I have x squared equal negative y over 1 minus 3. Okay. And I multiply. Do we not use quadratic formula? Yes, you can. You can, of course. You can use quadratic formula for this as well. But I'm just more into factorize it. And I multiply negative 1 to both numerator and denominator. So I get something like this. So I know that I can have two solutions here. I can have it plus or minus square root of y over 3 over minus y. But I will pick only one because I just need to show that there exists x. I don't have to show all the x that I can get. So I will pick the positive value. Okay. So that is my rough work, and in my proof, I will say that I pick x equal to square root of y over 3 minus y. But first, I have to explain why I can take a square root of this. Because remember, we can only take square root of a greater than or equal to 0. So inside the square root, it have to be greater than or equal to 0 so that we can square root it. So I know y is greater than or equal to 0 because we pick y from this interval, right? Sorry, it's round bracket here. And y is less than 3, so 3 minus y is greater than 0. So both numerator and denominator is a non-negative number. So it is greater than or equal to 0. So square root of y over 3 minus y axis. Take x equals square root of y over 3 minus y. And x is a real number, obviously, because every number here is a real number. And when you divided a real number by a real number, you have another real number. And f of x would be 3 times square root of y over 3 minus y squared divided by square root of y over 3 minus y squared and plus 1. In this step, you will just break it out, like expand the square out, so you will get rid of these, no longer have this, and no longer have this, only the number. And then after a bunch of computation, you will get this equal to y. And you can conclude that y is in f of r. So you started with y is in the interval, and you finish it by saying y is in f of r. Therefore, the interval is subset of the image. And in the part 1, we proved that the image is subset of the interval. Therefore, they are equal. So that's how we do the proof. I think we are running out of time. So you will think about this question. I tell you it is A, and think about how to prove it. I will upload the note right after the tutorial. And for this one, it was the last semester quiz. I will tell you how I find the image. So firstly, as I said, I will think for lower bound, I will observe whether something is greater than or equal to 0. And I have these, right? So I have something like this. So this one is fx. And f is from r times n to r. So I will observe if there is something greater than or equal to 0, like x squared, absolute value of x, square root of x. So I have absolute value of x is greater than or equal to 0. And look at here, y is a natural number. And a natural number is 1, 2, 3, 4, dot, dot, dot. So it is also greater than 0. So x, absolute value of x times y is greater than or equal to 0. So 2 times absolute value of x times y is also greater than or equal to 0. So 2 times absolute value of x times y plus 1 is greater than or equal to 0 plus 1, which is 1. So the minimum value of the function would be 1. How about a maximum? I will think about if there is something to stop f from growing. Right, so as x go to infinity, absolute value of x also go to infinity. As y go to infinity, right, the value of y will get larger and larger, right? So as x and y go to infinity, absolute value of x times y will go to infinity. Like there's nothing to stop it from growing. So even if you times 2 and you plus 1, it will just be infinity. That's why I know the image would be 1 up to infinity. Okay. And in your proof, in the first part, proving the image is subset of the interval, you will just need to say this. If you prove that f of x is greater than or equal to 1, if you have a is greater than or equal to 1, it already means a belong to this interval. So you don't have to say this part because it's calculus. But you need to use this part in your rough work to see if you have any upper limit, like upper bound. But in your proof, the first part, proving image belong like is a subset of the interval, you just need to write this part, okay? And for the second part, you want to prove that the interval is subset of the image, right? So when you have two input, normally you have to fix one. Why? Because we just need to show that there exists input such that when you give the input in, it will give us the desired output. So I need to fix either x or y and write the other variable in terms of it. And I would choose to fix y here. Why? Because y is a natural number. Not every expression that you get will give you a natural number. However, a real number, then whatever expression you get, as long as it is not like square root of a negative number, as long as it's not this, then everything will be a real number, like square root 3 over 2, square root 3 over square root 2. Everything is a real number. So that's why I choose to fix y. Let's fix y equal to 1. Choose a number from the interval. I want to show that exists a pair of xy such that fxy equal to z, right? So in my rough work, I will think 2 times x, absolute value of x, and then times y. And if I fix y here is 1, and plus 1 equal to z. Not write it here. First thing, just write this, like choose z from an interval. And we want to show that exists a pair of xy satisfy that is f r times y is the image. The domain is given. The domain is here, and this one is codomain. But f of domain is the image. Okay. So in my rough work, I will be like, if it is y, then I need to fix something in order to write it in terms of, right? So I fix y because n is a smaller set and it have more constraint. That's why I want to fix y and write x in terms of z. And then I would have 2 times absolute value of x equal to z minus 1. an absolute value of x equals z minus 1/2, then you can pick x equals z minus 1/2. Like there's another solution to this, which is minus of this whole thing, but I just need one solution to talk about in my proof. So in my proof, I would say pick z minus 1/2 and 1, since z belong to R. So z is a real number, so z minus 1/2 is a real number. So this satisfies it is in R, and 1 is a natural number. So the input we just choose is in the domain. The pair of input we just choose satisfy the domain. Okay, and then you will plug it in. F of z minus 1/2 and 1 would be 2 times absolute value of z minus 1/2 times 1 and plus 1. And how do I get rid of the absolute side? So I know that z is greater than or equal to 1 because we pick z from this. So z is greater than or equal to 1. So z minus 1/2 is greater than or equal to 0. So absolute value of a non-negative number equal to itself. I remember these. So that's how I get rid of the absolute value, the absolute psi, and times 1, it's just the number itself. And these two cancel out. I get z minus 1 plus 1, which is z. So I just show that there exists a pair of input that can actually produce z. So that's how I prove the interval is subset of the image. Okay, I will go over the field part real quick. So there's nothing much that I can talk to you about except this definition. So we had to fix a real number instead. We can still pick one. Fix a real number. Yes, the problem is if you fix x is 1, if you fix x is 1 and z is a real number, right? Z can be like 2.12345 like this, right? Then when you get y in terms of z, like y equals z minus 1/2, then y is not a natural number. So it doesn't satisfy the domain. It doesn't satisfy domain condition. So that's why I choose to fix a number that have less, so have more constraint, like have more restriction on it. Because the other one is more flexible and it can be whatever number. Okay. So for the field question, if they ask you if something is a field, what you have to do is check all these 6 conditions. There's no other way. You have to check every condition. And if it passes all the conditions, then it is a field. And if it fails only one, it is still not a field. So the important thing about a field is we are running out of time. You can leave if you want, but I will still go over it. Do we have to prove that it passed all of the? Yes, that's the problem. So I never see a question that asks me in the test to prove something is a field because it's really long. Normally, it will violate one of the rule, and I point it out and say that is not a field. Okay, so the first thing you will look at is whether it have additive identity or multiplicative identity. It have to have both of these. So that's the first thing I will look into to check whether it's a field. Existence of additive identity and multiplicative identity. The second thing I would look at is closure under addition and multiplication, which means if you pick two numbers in the set and you multiply or you adding it, it should still produce a number inside the set. It should not be a number outside of the set. Okay, that's what it means. Like the sum of two numbers in the set have to be in the set, and the product of two numbers in the set have to be in the set. So I check this one first, then I check this one, then I will check existence of negatives and reciprocals. Okay, and then if they actually pass all these three, I will have to just check these three left. So I don't have preference over these three conditions, but yeah, from my experience, I will check from these, then this, then this. Because I just feel it's more difficult to fill these than filling these three. So that's why I check the three first. So in order that if it fills any of the first three that I check, it is not a fill. Okay. So let's do this question first because 4 is pretty long. What do you think? What is A? F is a field and you have 0, 1 plus 1 is 0 and A squared equal to 1. You don't know how many elements are there in the field, but you can calculate those expressions. Start with 1 plus 1 is 0. Okay, let's see. We have 1 plus 1 equals 0. Then what do we do? Yes, so we can multiply A on both sides, right? And in this step, how do we break it out? Yes, distributivity, right? So we have x times y plus z equal to x times y plus x times z because a field have distributivity. A times 0 is 0 because it is a definition of yeah, I think we prove it a claim. It is not in field axiom, but we prove it as a claim in the note, so you can use it. Therefore, A plus A equal to 0. How about B? I don't know why I always write so big. It's running out of space all the time. Substitute A squared equal to 1. Okay, but how do we get A squared? It is 1 plus A and square. Can you explain A again? Yes, so we are given 1 plus 1 equal to 0. So I started with it. And then I multiply A to both sides, right? And then I expand it out using this law, like A times 1 is A plus A times 1 is A. And on the right hand side, A times 0 is 0. So A plus A equal to 0. Yes, we can expand in field. We cannot use like the quadratic, how to say it, like A plus B squared equal A squared plus B squared plus 2AB. We cannot use that. We don't know that in field, okay? However, we can multiply it manually. 1 plus A times 1 plus A, right? It will be 1 times 1, which is 1, because it is the what is that? Is a multiplicative identity. So 1 times any number is the number itself. And then 1 times A is A because 1 is multiplicative identity. A times 1 is A here. And A times A is 1 given here. And then I just plus the 1 outside the bracket left. Okay. I have in part A plus A equals 0. So 1 plus 0 and plus 1 and plus 1. 1 plus 0 is 1, right? Because 0 is additive identity. Then I plus 1, then plus 1. So the first two 1 plus together, it will be 0. Because we are given that information. Then we plus the last one. 0 plus 1 will be 1. Because 0 plus any number is itself. And 1 multiply any number is equal to itself. Okay. For part C, what is negative of A? We start with A squared equal why there should be 1 plus 1 equals 0 rule because it is given. It's just the information given in this question. It's not true for every field, but we are given that information in this question. Okay, for C, we care about negative of A. So negative of A is a number. Let's say is a number B such that A plus B equal to 0, right? We can plus A both sides. Yeah, so if you can see negative A plus A like this, then what do we get? We just get 0, right? And what is 0? Okay, 1 plus 1, but if we get 1 plus 1 here, what is the next step we can do? Correct, it is A plus A. That's why I give you this step, right? We need to use it in B and then we need to use it in C. We have negative A plus A equal to A plus A. And if you plus negative one more times like this, I think I should write it. Okay, so we have negative A plus A and plus negative A one more times. So A plus negative A will be 0, okay? And A plus negative A will also be 0. Negative A plus 0 is negative A. A plus 0 is A. So negative A equal to A. And then inverse of A. Inverse of A is a number such that like we have something multiply with A equal to 1. And that something will be negative A inverse. What should I have here? Yes, it's A. It's given here. A squared is A times A, right? And we have A times A equal 1. It's similar to this. So the question mark here is actually A. So A inverse is A. Is there any question? Okay, so there are two questions we couldn't go over. This one I will give you the answer. So the additive identity will be 0, 0, and multiplicative identity will be 2 and 2. I will give you a link to the answer because I actually solved this one last semester. So I can give you the answer right after I end this meeting. And also this part, this one I also solved it. So I will give you the answer link as well. If there is no question, I will stop the tutorial today.